The purpose of this video is to show the integrated HotScan system being tested at 250 degrees Celsius in laboratory conditions. This is a high-temperature transducer, and here is a color array populated with these high-temperature transducers. This HotScan pulsar receiver unit is designed to drive that transducer color array. A representative P91 pipe specimen was prepared, and a sample weld was produced to identify the heat-affected zone. Here is a macro image of the cross-section of the sample weld. The gray region surrounding the weld cap is the heat-affected zone, which was analyzed under a microscope. An 8-inch, Schedule 40, P91 pipe was welded and prepared. Here is the experimental setup. The pipe was heated up to 250 degrees Celsius using heating mats. The temperature of these heating mats was controlled by a thermocouple attached to the heat treatment module. This thermocouple was resistance welded to the pipe. Once the transducer color array was at 250 degrees Celsius, a defect was manually added in the heat-affected zone of the weld. The size of this defect was gradually increased from 0.25% to 9% cross-section area, and the data was collected for each defect size. A script was used to automate the data collection over time. The temperature was recorded using a temperature logging software. This data was then processed by the HotScan software. This is the graphical user interface of the HotScan software. To begin the processing, the inspection range in meters is fed in as shown. Subsequently, the baseline data files are imported. Finally, the test files are loaded and the results are computed as shown. Depending on the size of the defects, they are categorized as small, medium or large and are plotted as shown. The defects are mapped as red features on the figure representing the pipe. Now that the HotScan system has been shown to work successfully in laboratory conditions, it will be tested on site in the near future. Thanks for watching this video. For more information see www.hotscan.eu.